This is lesson number 2. Let's read it together and fill out the pencil exercises. Electronic component identification. Objective. In this lesson, you will learn the physical appearance, schematic symbol, and the basic function of all the following components: batteries, switches, resistors, potentiometers, photocells, ceramic capacitors, electrolytic capacitors, diodes, LEDs, SCRs, transistors, integrated circuits, and speakers. First, batteries. There are several types, but with this lab we're going to use a 9-volt battery. To the right of the battery you will notice that we have a schematic symbol. And I want you to draw that symbol on your paper, on that lesson paper that you have. And the function of a battery is that it stores electric energy. The next one is switches. You can see 2 switches that are there. One we call a slide switch, the other one's a push button switch. You can see the schematic symbols, and I'd like you to draw those on your paper when you get a chance. The function of a switch or a push button is a device that opens or closes an electric circuit. Switches or push buttons may have any number of terminals. They need to at least have 2. Identify the switch in your lab and observe it. The next one on the right-hand column is resistors. You'll notice that we have a resistor drawn with color bands on it, and then to the right of that is the resistor schematic symbol. I'd like you to draw that schematic symbol. The function: a resistor limits and controls the amount of current flowing through a circuit by presenting an opposition or resistance to the current flow. Identify the resistors in your lab and observe them. Next, we have potentiometers. Notice we've drawn a potentiometer there. It looks like a little volume control. It's got a shaft that you can twist, and it's a variable resistor. And you can draw the schematic symbol on your paper. The function of a potentiometer is a variable resistor. You can identify the potentiometer in your lab. The next one is a photocell. We've drawn one there that has 2 leads on it. The schematic symbol shows arrows pointing in like the light coming down on it. It's got a resistor symbol in the middle of it because the resistance changes on a photocell depending on how much light is on it. The function of a photocell is a special kind of resistor that varies its resistance according to the intensity of the light that hits its surface. Identify the photocell in your lab. Now go to page 2 of 3 of the electronic component identification. You'll notice at the top on the left that we talk about ceramic capacitors. You can see they're just a little capacitor that has 2 leads sticking out of it. You can see its schematic symbol. I want you to draw the schematic symbol on your page. The function of a capacitor acts as a temporary battery storing electricity. Ceramic capacitors store small amounts of electricity. Identify the ceramic capacitors in your lab. Next, we have electrolytic capacitors. You can see their appearance. They look like a small can with 2 leads sticking out. One lead is longer than the other. The long lead is positive. The short lead, of course, is the negative. Also, lots of times has a stripe on the side to indicate the negative side. Notice the schematic symbol. It's labeled with a positive and a negative. Go ahead and copy that symbol on your paper. Function: electrolytic capacitors store relatively large amounts of electricity. They have polarity. Not all of them do, but the ones in this lab have polarity, which means that they have a positive and a negative terminal. Therefore, care must be taken when connecting these capacitors to a circuit. They must be installed in the right orientation or right direction. Identify the electrolytic capacitors in your lab, observe them, and note indicated polarity of their leads. The next one are diodes. You can see the schematic symbol of a diode. You can see its physical appearance. It seems to have a little white band around one end of it. That indicates the cathode. Notice the symbol. Copy the symbol onto your paper. Function: a diode is a device that allows current to flow through it in one direction only. You can compare the diode to a one-way street. Diodes have 2 leads. One is the anode, the other is the cathode. and the cathode is indicated by a band around the body of the diode. So identify this and observe your diode in the lab. The electrons actually enter the cathode side and come out of the anode side. Next, on the right-hand side of your paper at the top, we have light-emitting diodes. These are pretty exciting. They come in many colors now. We have the physical appearance. It's a plastic lens with two leads sticking out. Again, this one has polarity. The long lead is positive. The negative is a short lead. You can see the schematic diagram, schematic symbol. See the cathode? Well, that's where the electrons enter, and then they come out the anode. Notice it has two arrows pointing away, thus indicating that we have light emitting from this diode. You'll notice that it has the same symbol as a diode, but in this case, it emits light. Function. LEDs are special kinds of diodes that emit light when current flows through them. They have two terminals called an anode and a cathode. The cathode is indicated by a flat side on the case. So what they do on the plastic part of the lens, they make a little flat side so that when they're soldered into a circuit where you can't tell what's a long and short lead, that you can tell which side is the cathode. It's the side that has that little bevel on the edge of the plastic. Identify the two LEDs in your lab and try to recognize the anode and the cathode leads. Next, we have SCRs, silicon control rectifiers. This means that it's a diode, but it also has a gate that you've got to give a positive pulse to it before it will actually allow the current to flow through it. And we use these in burglar alarms, color organs. There's a variety of ways that we can use this little device called an SCR. Notice that the symbol looks like a diode, but it has an extra line sticking out with a G for gate. And you can take your time and observe it and look at it. Also has a tab. That tab is also connected to the anode, the one that has the hole in it. Function. The SCR allows current to flow through it only after a momentary positive voltage is applied to the gate. SCRs have three leads, which are called anode, cathode, and gate. Identify and observe the SCR in your lab. The next item are in two different bags because you have an NPN and a PNP. They look totally similar. They're black plastic. They have three leads sticking out. Emitter, base, and collector are the three leads. You can see they're two different schematic symbols. If you'll notice carefully, the NPN has an arrow on the E or emitter lead pointing out of the transistor center, and on the PNP, it has an arrow pointing in toward the center. You'll learn more about this when we do the experiments. Function. A transistor is a component used to amplify electricity. It has three terminals called an emitter, base, and collector. According to how transistors are manufactured, they become NPN and PNP types. Observe the difference in the schematic symbol between these two types. Identify and observe the two transistors in your lab. Now let's go to page 3 of 3 of the component identification pages. The first item that comes up is an integrated circuit. This particular integrated circuit that we have in this lab has 8 leads sticking out of it. It's called a 555 timer. It's very, very well known and has many, many purposes, and we use it in a variety of ways. But we wanted to use this to indicate how you can use an integrated circuit to make different electronic projects. You'll see that it looks like a little bug with little legs sticking out of it. You see the schematic symbol has 8 lines coming out of it, showing that it has 8 connections in the one that we provide. The function of integrated circuits, they've got several components, transistors, diodes, resistors, capacitors, and everything all condensed into a very small package. Each type of IC performs a different function according to the different components it has on the inside. So you can identify the one that we're using. It's in bag 13, and look at it very carefully. and you'll see that there's a little notch or a dot or something to indicate where the first lead is because you count the leads, and we'll explain how this all works when we build some different projects. The next one is something that you use constantly: speakers. We explain how a speaker works, what it does, what its purpose. It's really ingenious. You can see a picture of one here where we've drawn it. You can see the schematic symbol. It's got two connections in this particular case. The function and the purpose of a speaker is to produce sound waves from electric current that flow through it. And we're going to use this in a variety of projects where we need sound. Now notice the schematic diagram chart. We've got the battery schematic diagram or symbol. To the right of that is a switch, like a slide switch. To the right of that one, we kind of show a push button switch, then a resistor, potentiometer, photocell, ceramic capacitor, electrolytic capacitor, diode, LED, SCR, NPN, PNP transistor, integrated circuit speaker. And the last one is a symbol for ground. And sometimes on circuits, you'll see that symbol. That really means generally the negative side of your circuit is connected to that particular place. All right, we have finished up our lesson on electronic component identification, and we're now ready to go to the resistor color code lesson number 3. At this point, I would like to remind you that by completing these lessons, you are earning a certificate of training for the Mr. Circuit Basic Electronics Lab number 1. This will be an important milestone and a nice addition to your resume. I hope you're enjoying learning electronics and will want to make it part of your future.